For years, Pluto was written off as a forgotten ice ball, drifting at the edge of our solar system. But the James Webb Space Telescope has just changed everything. Beneath its frozen heart may lie a hidden ocean, and maybe even signs of life. Once thought dead, Pluto is turning out to be one of the most mysterious worlds we've ever studied. The question is, what secrets are hiding under that icy shell? Pluto, the forgotten world with hidden secrets. When Pluto was reclassified as a dwarf planet in 2006, it lost its status as the ninth planet and, in the eyes of many, became little more than an icy leftover drifting at the edge of the solar system. Once celebrated, it was suddenly dismissed as a frozen relic with little scientific importance. But that view has been changing in astonishing ways. Thanks to the James Webb Space Telescope, JWST, Pluto is being reimagined not as a silent, frozen rock, but as one of the most intriguing worlds in our solar neighborhood. The new high-resolution images and data suggest Pluto is far more active and mysterious than scientists once believed. Beneath its icy shell may lie processes, and perhaps even possibilities, that could change how we think about life beyond Earth. The heart of Pluto. At the center of Pluto's mysteries lies its most famous landmark, Sputnik Planitia, the massive heart-shaped glacier that has captured imaginations worldwide. Made mostly of frozen nitrogen, this glacier is so large it actually shifts Pluto's rotation and alters its balance in space, as if the planet itself is weighted on one side. But what's beneath this bright plane is even more fascinating. Scientists suspect that under its kilometers-thick crust of ice, Pluto may hide a liquid ocean, kept from freezing by heat radiating from its rocky core. Despite being nearly 6 billion kilometers from the Sun, this residual warmth, produced by slow radioactive decay deep within, may be enough to keep water liquid below the surface. If true, then Pluto isn't just a frozen world, it's a living, evolving planet. And if there's water, there's the tantalizing possibility that some form of life could exist there. A restless world. Signs of activity support this idea. NASA's New Horizons mission in 2015 revealed a surface full of fault lines, ridges, and fractures, features more common on dynamic planets than on dead ones. These scars suggest Pluto's interior is restless, reshaping its surface over time. Adding to this mystery is Pluto's unusual gravitational relationship with its largest moon, Charon. Unlike most moons, Charon doesn't orbit around Pluto directly. Instead, both worlds circle a point in space between them, locked in a delicate cosmic balance. This interaction produces tidal forces that may flex Pluto's crust and stir its hidden ocean, generating additional heat. In other words, Pluto is not drifting quietly in the dark. It is active, restless, and perhaps even alive beneath the ice. The possibility of life. Some researchers have gone further, suggesting that Pluto's subsurface ocean might harbor microbial life. Any such organisms would live in complete darkness, shielded by thick ice from radiation and extreme cold. To survive, they would need to adapt to high pressures and frigid waters. But life on Earth has already shown us that biology can thrive in extreme environments, from deep ocean vents to Antarctic lakes. Even more puzzling, JWST has detected unusual heat patterns and chemical traces around Pluto that resemble processes linked to biological activity on Earth. While these findings are still unexplained, they raise unsettling questions. Could Pluto host life forms so alien that they challenge our very definition of what life is? Atmosphere and chemistry. Pluto also has a thin but surprisingly active atmosphere, made mostly of nitrogen with traces of methane and carbon monoxide. Sunlight interacts with these gases, creating a reddish haze rich in tholins, complex organic molecules that are thought to be precursors to life's chemistry. Charon, too, adds intrigue. Strange red caps have been observed at its poles, possibly formed when gases escaping Pluto drift over and freeze on its moon's surface. Together, the pair may share chemistry, and perhaps more, across the vacuum of space. A Kuiper belt outlier, Pluto doesn't sit quietly in isolation. It is part of the Kuiper belt, a vast region beyond Neptune filled with icy remnants from the early solar system. Most Kuiper belt objects are small, frozen, and inactive, time capsules left over from the chaos of planetary formation. But Pluto is the outlier. It refuses to conform to expectations. Where other Kuiper belt bodies are quiet, Pluto is alive with motion. Its nitrogen glaciers creep across the surface. Its atmosphere expands and collapses with the seasons. Its reddish haze speaks of complex organic chemistry. In a region we once thought of as frozen and static, Pluto shines as the exception, a world of change, defying the silence around it. This raises a profound question. If Pluto is active, what about its neighbors? Could other worlds in the Kuiper belt also be hiding subsurface oceans or strange chemistry beneath their crusts? If so, then the outer solar system may be far richer and more dynamic than we ever dared to imagine. The next chapter for now, our understanding of Pluto comes mostly from a single fleeting encounter. In July 2015, NASA's New Horizons spacecraft flew past Pluto, sending back breathtaking images of mountains, plains, and haze-filled skies. But it was only a snapshot, a quick glimpse before the probe sped deeper into the Kuiper belt. To truly unlock Pluto's mysteries, we will need more. Future missions may carry orbiters to map its surface in detail, landers to analyze its icy crust, or even drills to penetrate its frozen shell and search for liquid water below. With the technology of the coming decades, we could one day sample Pluto's chemistry directly, perhaps even detecting the fingerprints of life itself. And then there is the mystery of a possible magnetic field. Though not yet confirmed, hints suggest Pluto may generate its own protective shield, guarding its atmosphere and ocean from the harsh radiation of space. If proven, it would not only change how we understand Pluto, but also challenge assumptions about what small worlds are capable of sustaining. A world of surprises. The more we look, the more Pluto overturns our expectations. Once dismissed as a frozen relic, it now reveals itself as a world of complexity and surprise. Its glaciers move like rivers. Its surface reshapes itself, erasing old scars and carving new ones. Its atmosphere forms hazes that rise and fall with the seasons. And beneath it all, there may be an ocean of liquid water, perhaps still active, perhaps even harboring life. Pluto forces us to expand our definition of what makes a planet alive. It blurs the lines between habitability and hostility, showing us that the conditions for life might exist in places we once ignored. The big question: so what is Pluto truly hiding? Could its frozen heart conceal a silent ocean, stirred by heat and tidal forces from its moon? Could alien chemistry be brewing in the dark, forming molecules that echo the first steps of life? Or could there even be living organisms, microbes adapted to the cold and pressure, existing in a world without sunlight? The answers remain locked beneath kilometers of ice. But every new observation, every hint from telescopes like JWST, brings us closer to uncovering them. A reminder in the darkness until the next mission arrives, Pluto remains one of the most mysterious worlds in the solar system. A frozen frontier, yes, but also a place of riddles, energy, and potential. It reminds us that exploration is never finished. Even the smallest and most overlooked worlds can hold the biggest surprises. And sometimes, the most important discoveries come from the places we least expect. So as our instruments sharpen and our reach grows ever farther, we may soon learn the truth about Pluto. Until then, it waits, on the edge of sunlight, in the twilight of the Kuiper belt, a distant reminder that the universe is still full of secrets. Keep watching the skies. The next great discovery might not come from a galaxy far away, but from a tiny, icy world we once thought we knew.